A resort in the Swiss Alps features a cable car that travels from the resort station to the mountain station. Engineers are fixing a cable car that unexpectedly stopped shortly before it reached the mountain station, as we can see in the diagram here. The engineers are ready to test the cable car. For the purposes of the test, the cable car will initially be at rest in its current position. Now that's important. V equals 0 when t equals 0. It will head up the mountain, stop at the mountain station, and immediately return to the resort station where it will stop and the test will be complete. The test begins and engineers believe the acceleration of the cable car during the test will be A is equal to kt squared minus 23t plus 20k, and measured in meters per minute squared. The variable t is the number of minutes from the moment the cable car leaves its position, and k is a constant. After 2 minutes, the engineers expect that the cable car will be travelling with velocity 18 meters per minute and will not yet have reached the mountain station. So, since time is in minutes, we're looking at v being equal to 18 when t is equal to 2. So, to get to velocity, we need to integrate acceleration. So that is going to be kt cubed over 3 minus 23t squared over 2 plus 20kt plus some constant. Now, v is equal to 0 when t is equal to 0 will give us that c is equal to 0, and so v is going to be kt cubed over 3, take away 23t squared over 2, plus 20k. But we also know that v is equal to 18 when t equals 2. And I nearly missed putting the t here. So, v is 18, t is 2. So that's going to give me 8k divided by 3. Take away, now t is 2, t squared is 4, so that's going to be 46. And if t is 2, that's going to be 40k. Let's just solve for that on the class pad. So we're going to have a solve. 18 equals 8x over 3. Take away 46, add 40x. And that gives me that x is equal to 1.5. So we now have the value of k, it is 1.5. Once the cable car leaves the mountain station, how long should it take to return to the resort station? Well, we know that it starts stationary here. So v is equal to 0 there. V is going to be equal to 0 when it arrives at the mountain station, and then it's going to go back down and it will be 0 again at the resort station. So those are the 3 zeros we should get. Now that we know that k is 1.5, we've got 1.5 t cubed over 3, which we could simplify. Take away 23 t squared over 2. And 20 times 1.5 is 30, plus 30t. And we want that to be equal to 0. And again, let's just solve for that. So, going to do a solve, and we want 1.5 x cubed over 3, take away 23x squared over 2, add 30x. We want to put that equal to 0. And let's see what times we get. 0, 3, and 20. So we've got t equals 0, 3, 20. And it follows that this is the start of the test. This is the mountain station. And this is the resort station. So since the time is in minutes, it should be 20 minutes to return to the resort station. Unfortunately, 10 minutes into the test, the cable car breaks down again. According to the engineer's model, how far is the cable car from the mountain station at this time? Okay, so if I do the integral from 0 to 3 of the velocity, that will give me the distance from the start point up to the mountain station. We know that it stops here at t equals 3. So let's do that. And once again, that is a class pad. So I want to do the integral from 0 to 3. I've got the velocity just there. Let's just drag that in there. And let's do that, and that's 41.625. And now let's see the position after 10. So all I need to do, let's just drag that to there, change that to 10, and that gives me negative 1083.3 recurring. So we're saying that it went 41.625 up here, and then it's traveled downwards, and this will be its position relative to the start position, which would be 0. So this is 1083.3 recurring from here down to where it stopped. And of course, this one was 41.625. So I think if we just add together the modulus of those answers, so if we drag that without the minus to here, and then add the 41.625, we get 1125. So approximately 1125 meters. There are, of course, other ways of doing that. What you could do is just take the time from 3 to 10, and if you do the modulus of v of t dt, it'll ignore the negative sign, and you'll get the distance travelled from t equals 3 when it's at the mountain station to t equals 10 where it stops. So that would be another way of doing the same thing, possibly simpler than what I did in the first place.